Hi everyone. Plan for the recording is to talk through our final FRQ, talk through the 6 problems. Notice I have the scoring guideline and my work up, so I'll kind of just walk through both. And the purpose of not just handing you the scoring guidelines is I think it's important to kind of talk through where some of these things come from and kind of some hints in the directions or in the question of how to answer the problem. So it's kind of my goal is just to talk us through how to do them. So as I read this first problem, some of the things we want to make sure we notice is our units. If you want to underline the units, that might be helpful. The G of T, our equation, is given in cubic feet per minute, so it's a rate of change. Super important to notice that. And then at the time equals 0, the silo is empty. So G of 0 equals 0 is another way of saying that. So those are 2 big things. And if you wanted to write somewhere on the paper, G of 0 equals 0, that might be helpful also. So maybe we just put G of 0 equals 0, just so that we don't forget our initial condition. Okay, question A. Approximate G prime. I have no function. All I have is a table. So I can't find G prime. I can't find the actual derivative of G. Well, the only other way of approximating an instantaneous rate of change is by doing the average rate of change. So if I want to find G prime of 3, I have to bracket that x coordinate of 3. So I have to look for values that are to the left and the right of the 3. So 1 and 5 will bracket 3. So I just do slope of a secant line, or the average rate of change. So G of 5 minus G of 1 over 5 minus 1. Y2 minus Y1 over X2 minus X1. And then from there it's pretty self-explanatory. This is a calculator-based question, and so I get 1.35. Technically, I should have a 0 on here if it really does come out to be 1.35. Now, units are super important. Using correct units. So my cubic feet per minute is my values of G, and I'm dividing it by change in minutes. So it's cubic feet per minute per minute. So it's the rate at which the rate is changing. Okay, all right. Interpret this at time equal 3, the amount of grain pouring into the silo, the rate at which grain is pouring into the silo is approximately 1.35 cubic feet per minute is what we should write. And I didn't write that out. So if you look over here at the scoring guidelines, you'll see how they wrote that. 1 point for the approximation, 1 point for the interpretation. For the approximation, I gave a point if the units were not correct, and I required the correct units to be in the interpretation. Okay, all right. Question B. Write an integral expression. Some of you did not write that. Make sure you see the directions. You get a point simply for writing the integral expression, even if you could not evaluate it. Okay, so write an integral expression that represents the total amount of grain. If I know a rate and I want an amount, I find the integral of the rate. Integrating rate gives me amount. So from where to where? From time equals 0 to time equals 8. So I'm integrating from 0 to 8 of my G of T dt. This had to be on the paper in order to get that first point. Notice on my scoring guidelines, 1 point for the integral expression. If you don't have that, you lose that point. Even if you did the Riemann sum correctly, you had to write the integral expression. So you could have gotten 2 points for the Riemann sum and a correct Riemann sum, but you could not have got this point for the integral. Okay, a right Riemann sum with 4 subintervals. So if I'm looking up here, 4 subintervals, I see 1, 2, 3, 4 subintervals. So here's my first, my second, and so on. Okay, so the height of my Riemann sum, the height of my rectangle, sorry, I'm finding from the right-hand side of that interval. So my change in x is 1 minus 0, which is 1. The height was 15.1. width, height of my rectangle. Next interval. The distance between 5 and 1 is the width of my rectangle. The height of my rectangle comes from the right-hand side of that interval. So it should be 4 times 20.5. The width of this rectangle is 1, and the height is 18.3. The width of this rectangle is 2. The height is 22.7. And my calculation looks like that. Using correct units, it's 160.8 cubic feet. That's how much grain has come into the silo, has been added to the silo from time equals 0 to time equal 8. And technically that's how much is in there because we started off with 0. Okay, question C. Grain in the silo is spoiling at this rate. So now I have an equation to determine the rate at which grain's spoiling. Okay, so again, we have a rate. It's cubic feet per minute. So I know how much was there from question B. At time equal 8, there's 160.8 cubic feet of grain in the silo. But over that same time interval, grain is spoiling at this rate. So my final calculation, or my calculation to find out how much is unspoiled, I take what is in there minus what is spoiled. So this tells me how much is spoiled. This is the total amount of grain, and the amount of grain minus what is spoiled is the amount that is unspoiled. This is just a calculation on your, oh, sorry. Wow, I can't believe I didn't write that. I was being lazy. I need a DT on that. Okay, that was not, yeah, I needed that on there. So there's my integral expression. If I cruise over here, yep, I get 1 point for the integral. So I need to have that dt on there. All right, this comes from the calculator. Just type that in the calculator. You get 13 point. Remember going 6 decimal places here? And I'm going to subtract them. 3 decimal places. There was a lot of you who did, I don't know, 4 to 6. I've seen all the way from 4 to 6. And I think even 1 or 2 of you did 147 point or 148. Yeah, be careful. 3 decimal places. Will it be marked wrong if it's not to 3 decimal places? Yes, it has to be 3 decimal places. I was nice. I did not take a point off for correct answer with more than 3 decimal places. They're not going to be so nice. You have to follow directions. 3 decimal places. Okay, I think that's pretty self-explanatory. Question D. Based on the model, is the amount of unspoiled grain in the silo increasing or decreasing? So the first thing is, what is the unspoiled grain? Well, the unspoiled grain is this right here. The, where am I at? The G of T. Oh, sorry, I gotta go back. This is the amount of grain. This is the amount of spoiled grain. So this is the amount of unspoiled grain. Or G of T is the rate at which grain is coming in, and W of T is the rate at which grain is spoiling. So the total amount, or the rate at which the unspoiled grain is changing is W, can't talk, sorry, G minus W. Okay, so that's how AP folks did it. They went G minus W of 6 and came up with a value. I simply found the value of each of them and compared them. Notice that we have our same idea. They say W of, the difference is greater than 0, and I said that it's G of 6 is greater than W of 6. They both are justifying my answer. They're both showing work that leads to the answer. This is the same idea if I move this over as G of 6 minus W of 6 is greater than 0. It's the exact same equation, just written a little different. Okay, so because the amount coming in is greater than the amount spoiling, the amount of unspoiled is increasing. Since there's more coming in than is spoiling, or the rate at which it's coming in is greater than the rate at which it's spoiling, the amount of unspoiled is increasing. How do I know that? Because G of 6 is greater than W of 6. Show work that leads to your answer. There's my, whoa, sorry. My hand caught a thing on my desk. There's my work that leads to my answer. Okay, so you had to have this. You have to show the work that leads to the answer. Okay? All right. Moving on. Question 2. Switching gears. Again, we need to go through and look at our information and highlight key things. Snails traveling along a straight path. Snail's velocity. So I need to recognize this is my velocity. Is that rate? Find the acceleration. This is just straight typing in the calculator. The derivative of velocity is acceleration. So I go derivative at a point, and I find v prime at 5. And it's simply that value. Again, 3 decimal places. What are my units? This is inches per minute. So I guess I should have highlighted that also. There's my units. And now we're doing inches per minute, the rate at which the velocity is changing, or inches per minute squared. Simply type it into the calculator. Okay, question B, displacement. Notice it doesn't say total distance traveled. Some of you had an absolute value on here. It ended up being the same because it was always positive. It didn't change, but that's technically not correct. It should just be the integral of the velocity. Okay, displacement, simply the integral of the rate. So integrate from 0 to 15 of v of t, and again, it's just typing it into the calculator. Hopefully those 2 questions were easy, and you got the 3 points for those 2 questions. For my scoring guidelines, question 1, simply 1 point for the answer. Question 2, or letter B, you got 1 point for the integral, so you had to show the integral, and then you get 1 point for the answer. Okay? Units are correct, or units are important. You had to have units. Okay, moving on. Question C. This was probably the first semi-hard one we've had on so far. At what time is a snail's instantaneous velocity equal to the average velocity? Instantaneous velocity equal to the average velocity. So let's look back at what we're given. I'm given an equation for velocity. How do I find average velocity when all I know is an equation for instantaneous velocity? Normally what you have is an equation for position, or you have a table with position. Not true this time. So how do I find average velocity when all I know is velocity? Think about how we described average value. The average value of a function is the average value of whatever function you have right here. So if I'm finding the average, or if I want the average value of, if I want to find the average value of velocity, then my velocity equation is what needs to go here. So the average velocity is 1 over b minus a, and that whole mess. That was the hardest part. It's conceptually knowing in order to find the average velocity, I have to do average value. Some of you did v of 15 minus v of 0 over 15 minus 0. Think about what that finds. If I have v of 15 minus v of 0 all over 15 minus 0, I'm finding the change in velocity over the change in time. That's acceleration. So if I did this right here, I didn't find the average velocity. I found the average acceleration. Okay? Make sure you recognize that, because there was 3 or 4 of you who did that. Okay, so what I want is to find the integral. And again, the hard part was recognizing I had to do the average value, even though this says find the average velocity. Okay. This we already know. We can do that on a calculator. Here's your slide over here. Here's my values I should have came up with. I'm on question C, right? Yeah, so there's my average velocity, and I want to set that equal to the function, which I just showed here. I didn't finish this problem. I set that equal to the function, and I just type it into the calculator. So this comes up with a value of 5.06, etc. Set that equal to this function and hit solve. And the answer should be 6.031 minutes. 1 point for finding the average value, 1 point for finding the 6.031, etc. Okay, question D. Ant arrives at the snail's starting position at time equals 12, follow the snail's path during the interval of 12 to 15 minutes. It only took the ant 3 minutes to catch the snail. The ant travels in the same direction as the snail with a constant acceleration of 2 inches per minute. The ant catches up to the snail at time equals 15. Okay, so in 3 minutes, the ant traveled the same distance as the snail. One more time. In 3 minutes, from 12 to 15, the ant traveled the same distance as the snail. Well, back here somewhere, we found how far the displacement, or how far the snail traveled. He traveled, or she, 76.043. So I set the equation for the velocity, or the integral of the velocity, equal to my 76.043. Well, the first question then would be, where'd the velocity equation come from? All I know is acceleration. So how do you find velocity from acceleration? You integrate. It's a constant acceleration. So my constant acceleration is just 2. So if I integrate 2 from the I don't know the intervals, sorry. I have 2t plus c. There is my velocity equation. Notice in your scoring guidelines, you get 1 point for the velocity equation. Okay, now I can integrate that from 12 to 15 to find out the displacement. Again, integral of velocity is displacement. That displacement I already know is 76.043. So I plugged in, or I took the integral, plug in 15, plug in 12, solve it, set it equal to 76.043, and I solve, and I get c equals a negative 1.652. There's my c value. Stick my c value back in, and I get my new velocity equation. What is the ant's velocity at time equals 12? Put in 12 and work it out. We get 1 point for the correct velocity, that 2t plus c. You get 1 point for the displacement, which would be the equation right here. You get 1 point for the correct equation right here. And then you get 1 point for the correct answer. Okay? All right. That was probably the hardest one on questions 1 and 2. Out of all the calculator stuff, that was probably the hardest one. Required the most work. Hopefully it makes sense though now that you've seen it done. Okay, switching gears, way down there. Calculator part. Make sure you know the area of a circle. I won't guarantee. There's a very good chance that it'll show up somewhere. Area of a circle is pi r squared. You have to know that. Okay. This is a graph of G. That's the first thing I would notice. This is a graph of G. Okay. F now is a new function with this definition. So f is 3x plus etc. Okay, so if I want to find f of 7, the 7 goes into every place there's an x in that equation. So 7 goes in for x, and I get 3 times 7, and 7 goes in for x up here. Integral from 0 to 7 simply says find the area underneath the curve of g of 7. Or not g of 7, but from 0 to 7. From 0 to 7. Well, from 0 to 6 is this circle thing, half circle. The radius of this circle is from here to here, which is 3. And my equation for circle is pi r squared. So I have pi times 3 squared, which would be 9 pi. And I have half of that because it's a semicircle. This circle is underneath the x-axis, so it's negative. Okay, so when I jump down here then, the then this right here is the integral from 6 to 7. So I have 1, 2, 3 squares. So my area from 0 to 7 is 3 minus 4.5 pi. Add that to the 21 from the first part of my definition, and there is my f of 7. Looking over at my scoring guidelines, I get, sorry, I had to cough there. I get 1.4 f of 7. Okay, f prime of 7. Well, first I have to find out what is f prime of x. F prime of x is simply the derivative of this. The derivative of 3x is easy, it's 3. The derivative of an integral, I take the upper bound, I plug it in, and I multiply by the derivative of the upper bound. So plugging in x gives me g of x. Times it by 1 just gives me g of x. So there is f prime of x. So f prime of 7 says plug in 7. So this is g of 7. G of 7 is just a value. At x equals 7, the g function is 3. And so I have 3 plus 3, which is 6. So I get 1 point for f of 7, and I get 1 point for f prime of 7. That wasn't a whole lot of difficult math. Hopefully we got it. Okay, question B. Most common mistake I saw on this one was finding or using the first derivative test to justify my answer. First derivative test does not justify an absolute max. It finds relative max and min. It doesn't justify an absolute max or min. Yes, I agree. I do some of the same steps. I find the critical values in both cases. But my first derivative test showing that my function goes from increasing to decreasing does not guarantee that that point is an absolute maximum. My end point could still be greater than that relative maximum. Okay, because there could be a minimum somewhere and causing it to not be a maximum. Okay, so first step, find the derivative and set it equal to 0 to find my critical values, because absolute max occur at critical values and endpoints. So my critical values are where my first derivative is equal to 0. So I set f prime equal to 0. So that's where g, remember f prime? We already did that. There's f prime. So it's where 3 plus g of x equals 0. So g of x has to be a negative 3. Where on my graph is g of x a negative 3? Right there at positive 3. So x equals 3 is a critical value. So my endpoints and critical values is what I want to check. Well, 3 is an endpoint, so I only have 2 points to check, the endpoints. So negative 4 gives me that. Positive 3 gives me that. This value is bigger than negative 16. So since f of 3 is bigger than f of negative 4, my f of 3 is an absolute maximum. Okay. Some of you and the AP folks did not do that. They said, since this graph is strictly, I'll just scroll over to it so you can read it. Because this f of x over that interval, f is a non-decreasing function over the entire interval. Okay, it's always positive. Therefore, the function has a maximum at the endpoint. If it's always increasing, then this right-hand side endpoint has to be the greatest point. Okay, so there's the other justification. This would be justifying my answer with this work, or saying that this is always positive and therefore the function has to be a maximum at the right-hand side endpoint. Some of you did a nice job saying that, but my definition or my justification also works. This is an extreme value theorem. Okay. Question C. Limit as x goes to 0 from the left of g prime. So what is g prime? G prime is the slope of g, right? So here's g. As I approach 0 from the left, my slope is a negative 1 over 2. As I approach, 0 from the left, my slope is a negative 1 over 2, constant. So the limit as x goes to 0 from the left is a negative 1/2. Okay, from the right. As x approaches 0 from the right, look at my curve. It goes semi-flat, still negative, but semi-flat. but then it increases to infinity. So this is a vertical line right here, right? This is a circle. So right here I have a vertical tangent. So my slope is infinite, which implies, that's that symbol right there, which implies my limit doesn't exist. Okay? 1 point for each. Let me cruise over here just so you can see that. Yeah, 1 point for the left-hand limit, 1 point for the right-hand limit. Okay, this one's a big one. Some of you did it right and didn't get all points, and here's why. Notice my scoring guidelines. 1 point when you set the limits, not set them, to show the limits equals 0. You had to show this right here, that the limit of the top equals 0 and that the limit of the bottom equals 0. They did it in 2 separate rows or 2 separate steps. I just did it in fraction form, which is totally fine. I put in -2 in the top, I got the top 0. Put in the bottom, I got the bottom 0. Okay, you had to show that. Some of you got like 2 over 0 and went to L'Hopital's, or 0 over 5 and went to L'Hopital's. That's not correct. If you got 0 over 5, your answer should have been 0. If you got 5 over 0, your answer should have been does not exist. Okay? And some of you didn't show any of that. You just jumped right to L'Hopital's. You can't go to L'Hopital's unless it's 0 divided by 0. And you had to show that. Okay? All right, so you got 1 point for showing 0 equals 0. You got 1 point for doing L'Hopital's rule, derivative of the top and the derivative of the bottom. And then you get 1 point for plugging in the -2 and working it out correctly. Okay, so f prime of -2 goes back to my definition of f prime. And f prime is this guy right here. So f prime of -2 says 3 plus g of -2. So cruise over here, g of -2 is 1. So this becomes 3 plus 1. This becomes 3 plus 1, which equals 4. And the bottom, when I plug in a -2, 3 times the -2 is a -6. -6 plus 6 is 0. E to the 0 power is 1. And 3 times 1 is just 3. And so I get 4/3. Notice there, notes, maximum of 1 out of 3 if no limit notation is present. Okay, if you did not show 0 over 0, the most you can get is a 1 out of 3. Okay. All right, question 4. Question 4. So looking at my graph, I guess there's not a whole lot to underline. I guess the first thing to recognize is that the f is bigger than the 3. Let me clarify. In the interval that we're talking about for question A, the f of x is greater than the 3. So my function, or my area, is going to be the function f of x minus 3. So this right here is my vertical line. F of x is bigger than 3. Okay. I did a little different. They went from a -1 to 1 over that whole entire thing. I showed that these two things are symmetric, so I just went 2 times 0 to 1. It doesn't matter. They're both the same thing. All right. Remember integral of 1 over 1 plus x squared is the arc tangent. So I just took that 6 and slid it out in front, and then it's going to be 6 arc tangent. Okay. They snuck one in there on you. You could get points without doing the antiderivative correctly, but that's what it should have been. And the integral of 3 is 3x. I evaluated from 0 to 1. You could have gone from a -1 to 1 also. Okay, continuing on. I should jump down here though. Let's look at the scoring guidelines. Scoring guidelines say you get 1 point for the integral. Okay, I get 1 point for the integral. That integral had to have the correct stuff. You had to have parentheses, you had to have your dx. Had to. If you didn't have parentheses and you didn't have the dx, it's not the correct integral. Okay, 1 point for the antiderivative, and then 1 point for correctly evaluating the arc tangent of 1 and 0, or 1, and negative 1. Where is arctangent equal to 1? Or what is arctangent of 1? Pi over 4. Remember my 45, 45, 90 triangle. It's 1, 1, right? My 45, 45, 90 is 1, 1, square root of 2. So arctangent of a 45 is going to be, or tangent of 45 is going to be 1 over 1, which is 1. If you had a negative 1 down here, you would have also had minus pi over 4. Okay? All right. And then I have 2 times 6, which is 12. And I have 3 times 1, which is 3, times 2, which is 6. That's where the 6 came from. I distributed this 2 to both terms. I just didn't show all my work. 12 divided by 4 is 3, and that 6 just is 6. Okay. Question B. This is my notes myself. So right, but do not evaluate. So all I'm looking for now is an equation. So let's go back to here. We're revolving it around y equals 7. So this is going to revolve up, and so on. Okay. So my larger y value is the 3. So my integral goes from 7 minus 3. From 7 to 3 is the radius of my longer circle, or my larger circle. This distance is 7 minus 3. And you could put 4 there also. So my formula is going to be pi times big R squared minus little r squared. So big R squared is that. Little r squared is just 7 minus the function. Whoops, wrong way. So this is my little r squared from here to here. So 7 minus the function. Remember, my function distance goes from here to here. 7 is from here to here. And if I subtract them, I get this little distance right here, which is r. So my formula is going to be from negative 1 to 1, or what I did before was 2 pi and then 0 to 1. That's fine too. And then it's big R squared minus little r squared. Throw parentheses around it. You don't have to write the function in there. Just writing f of x is fine. But if you rewrote the function, that's fine too. All right. So for this one, we get 1 point, 2 points for the integrand. This is called the integrand. We get 2 points for that. And you get 1 point for the limits and the constant. So 1 point for this and this. Okay. If you had the pi and your limits right and none of this right, you got a point. Okay. Question C. Let h be a vertical distance between point x and f of x, and the horizontal line y equals 3. Find the rate of change of h with respect to x at x equals 2. Okay. All right, this one's tricky. Not hard, but tricky. We now are going at x equals 2. At x equals 2, the vertical distance from here to here, the f of x is no longer the bigger function. 3 is now my bigger function. So it's now going to be 3 minus f of x to give me this vertical distance. So when they say let h equal the vertical distance between the point and the horizontal line, my 3 has to be first when I'm finding the horizontal distance. So there's my definition of h. Find the rate of change of h. What is the rate of change of h? Derivative. So I just did derivative of h. Derivative of 3 is 0. And I just did this as a quotient rule. I didn't do this as 1 over 1 plus x squared. And so I just did this as a quotient rule. Derivative of the top is 0 times the bottom minus the top times the derivative of the bottom all over the bottom squared. This is 0. This is a negative 12 times 2, which is a negative 24. And this is over 25. Okay. Okay, that was the tricky part. Just making sure you had those correct. All right. Oh no, sorry. That was a positive 24. I didn't see the double negatives. Trust my original problem. This negative here, I didn't see that. It was hiding there. So this negative makes that negative a positive 24. Sorry. My first answer was right. All right. Question 5. This one, people either got a lot of points or very few points, just depending upon if you understood the question. So use the line tangent to the graph at f graph of y equals f of t at time equals 0 to approximate the amount of substance. Remember, this is where we use our tangent line to approximate. So my first step is to find the equational line tangent at x equals 0. So how do you find the equational line tangent to a curve? You need a point and a slope. They told me a point. At the start of the reaction at time equals 0, there are 10 grams. There is my point, or there is my point. There's my x and my y. So what do I need? I need slope. Well, they tell me slope, kind of. They tell me the equation for the derivative. Plug in your 10 for y, because that's the y, or because the derivative is in terms of y. When I plug in the 10 for y, I get 100 times a negative 0.02, which is a negative 2. Are you expected to be able to do that without a calculator? Clearly, because they have it on a no calculator section. Yes, we can multiply 100 times 100th. It just comes out to be negative 2. Okay, so there's my slope. So y minus y1 equals m times x minus x1. So technically, I have that. Okay, but I don't need all that. And then I plugged in my value. So I plug in at time equals 0 to approximate the amount of substance at time equals 2. So I plug in 2 and I get negative 4. I add the 10 and I get 6 grams. So based on the tangent line at time equals 0, at time equals 2, it should be 6 grams. Question B. Using a differential equation, determine whether the graph given could be a graph for f. So looking at this right here, okay, y squared will always be positive, which means this function will always be negative. So my slope will always be negative for all values of y. So as y changes from 0 to whatever, my slope should always be negative. This cannot be the graph of f, because at this point right here, my slope is now positive. Okay, here's my verbiage. The graph has both negative slopes and positive slopes, and this is always negative. Therefore, or so, no, this cannot be the graph of f. We do need kind of this connector. Therefore, thus, which implies, wow, that was a horrible implies. I'm trying to draw with my mouse. Get my pen back out. So this is an easy one to write, which implies, okay, so that's another way of writing that, which implies this cannot be the graph. So have some kind of connector. This is what I know, which tells me something. Make sure you have that connector to say your thought process is leading you to this conclusion, or your work is leading you to this conclusion. Okay. C. This one, I don't know if I should say this, but I think we should have got this one. We've been doing this a bunch. We had, in chapter 6, this is all we did was free response questions. So I would make sure if we didn't get any points on this, or maybe got 1 point, we go back and brush up on separating variables and differential equations. Okay. Let me jump back over here so we can, I think we're good for that there. Question 5, there's my scoring guideline for question 5. Okay, question C. Look at all the points. You have 4 points here possible on question C. 1 point simply for separating the variables. Now, there's not a lot of people who made this, but some of you made this mistake, and you brought the negative 0.02 underneath with the y. Not completely wrong. You can do that. It just seems to be easier if you leave it over here. Okay, if you bring it with the y, then I would put it as 1 over a negative, etc. I'd put it out here. Okay, but I would not do that. I would leave it on the right hand side. Simply bring the y underneath. Okay, so you get 1 point simply for separating your variables. So if you got that, you got a point. Next thing, take the antiderivative. Remember, this is y to the negative second power. So I'm going to change, add 1 to the exponent, divide the old coefficient by the new exponent. So I add 1 to a negative 2 and I get negative 1. Divide the old coefficient of 1 by negative 1 and I get that. Well, this is simply that. I just skipped that step right there. So there's my antiderivative on the left. Antiderivative of a constant, just stick the t variable on there and your plus c. So you get 1 point for separating your variables. You get 1 more for finding the antiderivative. At this point in time, the AP folks plug, if you look at their work, they plug in the 0 and 10. That's totally fine. Okay, and they got C equals to 0.01. I waited, and I got C equal to a negative 0.01. That's fine. I mean, it's just, I already have my C solved for. I already took care of this negative sign and brought it over, which is why we have different signs for our C. If you plugged in the 0 and 10 and found C, you got another point. And finally, answer, meaning you solved for y correctly. So I plugged that back in and I solved for y. For this problem, I took any of these answers. Okay. This would be also a 0.1 would be fine if you had a 0.1 here. If you took all these negatives away and just make it positive, that was fine. Okay, almost any of the, not almost, any of these answers would be fine, and even with these all being positive would also be fine. Okay, 4-point question. Hopefully you got at least 2. Hopefully you can separate your variables and do the right antiderivative. Even if you did the wrong antiderivative and you plugged in the C value, you still get a point. So you should get 1, 2 points, I won't say easily, but fairly easily. Okay, question D. Determine whether the amount of substance is changing at an increasing or decreasing rate. So we want to find the derivative of the derivative. Is the rate changing? Okay, is the amount of substance changing? Okay, how is the rate of the amount of substance changing? Is it increasing or decreasing? So I have to look at second derivative. So I go back to my function. There's my derivative equation. So I need the derivative of the derivative. So I bring the 2, multiply it by this, decrease the exponent by 1, times the derivative of the y with respect to t. So I have negative 0.04y times dy dt. Well, dy dt is that negative 0.00, nope, negative 0.02 y squared. I multiplied those together, you get 0.000. I didn't actually multiply them, but the whole point here is these negatives go away. And it should be 0.00008 y cubed. Okay. Now, the question is this positive or is this negative? Well, my y values are all greater than 0, which means that this will be greater than 0, which means the function derivative, second derivative will be greater than 0. So the amount of substance is increasing. The rate at which it's changing is increasing at an increasing rate. Here's your points. You get 1 point for finding the second derivative correctly, and 1 point for the correct answer with correct reasoning. So the amount of substance changing at an increasing rate because my second derivative is greater than 0. Notice again my connecting word. Here's my work. Because this is greater than 0, this is true. Okay. Question 6. Last one. So here's my curve. Find dy dx. Do an implicit differentiation. So I'm looking back at this. I'm going to find the derivative of this. So what I did was I just distributed that 2. You didn't have to, but that's what I did. So I distributed the 2. Thought it might be easier. I'm taking the derivative of y with respect to x, or the derivative of this function with respect to x. So the derivative of 2x is 2. The derivative of 2y is 2 times the derivative of y with respect to x. So times dy dx or y prime. The derivative of 3 is a constant. Sorry, 3 is a constant. So the derivative is 0. Derivative of cosine is negative sine. Leave the inside function alone. Times it by the derivative of the inside function. Okay, move the 2y across, it becomes a positive 2y. Factor out the y prime, divide by 2 minus sine y, and I get y prime. So here's my breakdown of points. I get 1 point for doing the correct implicit differentiation. If you got to here, you got a point. And then I get 1 point for doing all this, solving down to here to verify that dy dx or y prime is equal to that function. Some of you had some weird derivatives and you just wrote dy dx equals that. No, it had to come from your work. It couldn't just be restated what we already have here. Okay, question B. There's a point on the curve between negative pi over 2 and pi over 2 where the slope is 1. First thing I did, set my derivative equal to 1. Why would I do that? Because the slope needs to be 1. Notice on my scoring guidelines, I get 1 point simply by doing what I just did. Set my derivative equal to 1. Boom, got a point. Now, find the coordinates of P. So where is this equal to 1? So I multiply by the denominator, and I get 2 times 2 minus sine y times 1, which is 2 minus sine y, equals 2. Subtract 2, and I get 0. Divide by negative 1, I still get 0. Where is sine equal to 0? Between these two values, at 0. How do we know that? Remember our unit circle. This is not a right triangle. This is going to be an xy intercept. Where's my y value 0? Between a negative pi over 2 and pi over 2. Between here and here, sine is 0, or y value is 0 at 0. Okay, take that y and plug it in, because I wanted an xy coordinate, right? Find the coordinates. So my y value is 0, so I put a 0 right there, and I put a 0 right there, and I solved for x. So putting a 0 here, I get 2x. Putting a 0 here, cosine of 0 is 1. So it becomes 3 plus 1, which is 4. Oh, I'm not sure why I did that. I subtracted 3, and then I added 3 back. Anyways, I get 4, divide by 2, and I get 2. So my point, 2, 0. Looking at my scoring guidelines, I get 1 point for setting the derivative equal to 0, 1 point for the correct point at 2, 0. All right. Question C. And I know some of you didn't even get to question C because it was blank. So let's just, if you want to hit pause and try it again, you can. Then we'll look at the work. Determine concavity. As soon as I see that, I'm thinking second derivative. Determine the concavity of the curve. So concavity, second derivative. Again, I did quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom. Derivative of the bottom. Derivative of 2 is 0. Derivative of sine is cosine times the derivative of the inside function, which is dy dx, or y prime. All over bottom squared. Okay, take the dy dx, which is this right here, sticks it back in for dy dx. So my top, this goes away because it's 0. And this is going to be 2 times, this is cosine, or this is 0. Negative, negative makes it a positive. So this will be 2 cosine of that big mess. Okay, here's some algebra skills. This 2, these are multiplied together, right? These are just 2 terms being multiplied together. This 2 minus sine y can slide to the bottom because it's a fraction, or you could say I'm multiplying both the top and the bottom by 2 minus sine y, and those will go away. But this slides to the bottom and gives me 2 minus sine y to the 3rd power, because I have 3 of them now. and this 2 times 2 is 4. Okay, so here's what I did. In between a negative pi over 2, wow, how do I have those upside down? Between a negative pi over 2 and a positive pi over 2, my cosine is always positive. My x coordinates are positive for this entire interval of angles. From a negative pi over 2 to pi over 2, cosine is always positive. So this is always positive. Okay, sine, okay, the sine of a function is always between negative 1 and 1. So 2 minus something between negative 1 and 1 is always bigger than 1. It's always bigger than 0. So this is always greater than 0. Therefore, which implies the graph is concave up because this is always greater than 0. I probably should have said that. Which implies dy y squared. So I would also say which implies dy squared dx squared, sorry, writing with my pen is not working well, is greater than 0. Which implies that. Concave up for all x is in between, all y is in between that value. Okay. Letter D. Probably, I won't say the hardest one on here, but it was super easy once you saw one little trick, but you had to see it. Okay, so here's my definition of mean value theorem. Average rate of change equals the instantaneous rate of change according to mean value theorem, somewhere in the interval. Okay, so what I want to show is that this is in between these two values. So I'm going to use this fact right here, and I'm going to go back to here. Where to go? Right here. So why'd they give me that right there? I haven't used it yet. Why'd they give it to me? If they give you something, I won't say always, but almost always, you're going to use it somewhere. So if you haven't used it, as you get towards the end, you need to go back and think, what are they giving me that I'm not using? So your first thing should be, if I'm stuck and not sure where to start, that would be a good spot to start. So I didn't catch that. I just started powering through it, and I'm not going to do it my way. Yeah, you can look at my way. You can hit pause and look at what I did. I just evaluated this right here. That sign, the biggest sign can be as 1 and the smallest sign can be as -1, back from what I just said right here. And so when I plug those values into my instantaneous rate of change, it does end up between 1/5 and 1/15. So that's what I did, which works. I mean, I would totally got all the points, but it's more intuitive than what they did. And theirs is, I like theirs. So let's look at this statement that they made, that dy dx is in between 2/3 and 2. Why? Because of what I just showed right here. So I just basically proved their little statement they made. So let's just use that statement because they told me it's true. Well, dy dx, we just said by the mean value theorem, dy dx is equal to that definition. So plugging in dy dx and that definition, I get 2.1 minus 2 is 0.1. Multiplying both sides by 0.1 or 1/10 gives me 2/30ths, which is 1/15, and 2/10ths, which is 1/5, and voila, I have the statement that they wanted me to make, that this is in between 1/15 and 1/5. That way is super easy to see. My way, again, I just basically proved this statement right here, and then I was able to use the mean value theorem to prove it. Here's my point value. Apply the mean value theorem. If you wrote this right here, you got a point, and then if you did this work, you got another point. Okay? All right. I hope that helps. It was almost an hour. If you listened through this whole entire thing, nice job. Hopefully it helps you for the end of the year test. Or for those of you who need to retake, hopefully it helps you retake it. Okay, goodbye.